So the big idea here is that the heat lost by that metal block is going to equal the heat gained by the water and the calorimeter cup. So the first thing we're going to do is calculate the heat gained by the cup and the water. So from the data table on the front side, the mass of the cup was 74.6 grams. It's made of aluminum, and the specific heat of aluminum is 0.217 calories per gram degrees C. The delta T of the cup was 11.3 degrees C. So we multiply those three together and we get 182.92, blah, blah, blah. The mass of the water, 150.1 grams. Specific heat of water is 1 calorie per gram degrees C. And the delta T for the water is also 11.3. Multiply those three together, you can get 1696.13. Add those two quantities and we get a total heat gained of 1879.0566, and we're not concerned about sig digs at this point because this is a temporary, it's not a final answer. Okay, so then we bring that down because the heat gained by the cup and water equals the heat lost by the metal block. So the mass of the metal block was 249.7. Specific heat is what we're solving for, and the delta T for the metal block is 64.7. Now I want to point out at this point how much greater the temperature change was for the metal block versus the cup and the water, even though the metal block was heavier. Something to ponder. Then to solve for C, we divide this by this, and we get 0.116 calories per gram degrees C. Okay, so we bring this down to number 3. The experimental value of the specific heat is the 0.116, and the metal block is made of iron. The accepted value of the specific heat for iron is 0.1075. So if we take our value minus that value, and divide it by the accepted value, and then multiply by 100, we get an 8.2% error, which isn't great, but given the fact I kind of rushed through the lab, I wanted to get the video done. Possible sources of error, temperature measurements, and then I noticed when I was transferring the metal block, there was a puddle of water, hot water. I tried to shake it off, but I didn't want the hot block to be in the cool air for too long. So I'm wondering if that hot puddle of water raised the specific heat of the metal by a significant amount. Now, you should be able to answer the rest of these questions and then submit it online. And I hope you're staying safe and well, and I miss seeing you in class. Take care and be well.